Good morning. Good morning and welcome. Um, we are going today through day number 3, and we should see some equipment that we have in GMA. Uh, we will not go through internal detail of the equipment, but just the, of course, which kind of equipment we have and general speaking, the characteristics of the equipment about input, output, uh, remote capability, remote through Ethernet if it is possible, or something else. Anyway, let's go. Um, the first thing that we have to do is the major part of these equipment are common in EQR1 and EQR2. That means we have not to do specific description for EQR1 or for EQR2. Is just a general one, and in this case, um, it's applicable the description in both environment. So what we have, the first equipment that we will see today is the PWS 4500, which is a Sony device. There are two of this equipment in EQR1 and two of this equipment in EQR2. Uh, generally speaking, this one is a record player or a record player device. It is not intended to be a record in the classical way, as you can imagine, with the tape or with the disc inside, because there are no tape, no disc inside. It's just a static recording, and its function is a continuous recording. Um, this configuration can record, I think, on two channel 10 or more, 10 or 11 hour, and the machine is always in record mode. If you need to see, let's imagine you have an event and the machine still recording, then you can catch some event into the recording and save it on a separate system. In this way, everything happen can be recorded and later on can be seen on the monitor or use it to do editing or whatever. The machine is supplied with 4 board, means 4 recording channel or player channel. Each channel can be record or play. It depends on the configuration, the initial configuration, initial setup of the machine. The channel are named A, B, C, and D. And in our case, on the machine, we have channel A and C are recorder channel, B and D are player channel. Each channel has some audio input AS. There are no analog input on the machine, just digital. And that means the machine can record audio and video together, but audio must be in digital mode. Can be supplied externally through the AAS line, or the audio can be embedded on the video. Of course, from a general point of view, The machine in this picture show 4 channel in and 4 channel out. But if you at the setup moment at the very beginning, you have set channel A record, B, C, and D player. Of course, your channel output should be only B, C, and D. A is a record, cannot have an output. Um, A, B, C, and D are just an identification of the hardware. What does it mean? It means, let's imagine that we have only channel A, which is a recorder, B, C, and D are player. Well, what has been recorded on channel A can be played independently on channel B, C, and D. So there is no direct relationship between record channel A, play on channel A. No, channel A is just a recorder which puts some contents into the memory. Then the memory can be read by any other channel which has been set as play out. This is valid for video and also for audio and video audio together. The machine can record just audio, but of course, to record, sorry, to record audio requires a video channel. That means uh, you may supply black on that channel and just record audio, but in any way, you lose one video channel. Machine as an external controller, which is composed by a computer supplied by Sony, which is a production control station, PR1, which is connected through the USB link with a remote system, PWS 4403, and the computer is connected to the machine through the Ethernet management LAN. So there are no controller or control panel or something else connected directly to the machine, but the machine is managed and controlled through the Pier 1. Of course, if there are two PWS 500, 5000, sorry, 4500, there are also must be two computer controller and two remote device. We will see that later on better. Um, the recorder has also some um, proprietary and specialized connection. We have two links Ethernet, and they are called SharePlay LAN. SharePlay LAN, it's a very high speed LAN. Each link is 10 gigabits, and through this link you can connect two PWS. Um, PWS can be one near the other, or through a fiber can be 2000 kilometer away. But it doesn't matter because through this high-speed link, you can use this machine or one channel of this machine as a remote channel on the machine on the other side. So that means you can play out uh, channel B, for instance, which is on the other machine, as if it is channel B on this machine, because the high-speed network allows you to transfer the contents instantaneously in play mode, even in 4K. Um, we have another, sorry, we have another connection, which is can be in fiber optics or Ethernet, which is called media file LAN. So the differences between the two is SharePlay allow you to put in play one machine on one side and see the output on the other machine live. Media file is something which is working uh, underground. So along that the operator is using the machine for some reason, recording, play, normal user. There can be another user which completely independent from the machine situation can store and read files internally and export or write file internally to another server. Uh, this is very useful because the two world, the operation world, production world is completely separate from the post-production world, which is performed by the media file LAN management. Sorry, just a minute. Some question?
Maurizio,
No?
please. Maybe I
Yeah,
missed something. About this equipment, you said that it can record, but without
yeah.
discs.
We can record, yes.
But without discs.
Without this, we cannot record. Yeah.
So we have discs inside this equipment.
We have two in EQR 1 and two in EQR 2.
Okay, I missed just that. Thank you.
Okay. So this is the configuration that we have maybe in EQR 1, where we have PWS number 1 and PWS number 2. On both machine, we have channel A and C video input because are recording channel. Channel B and D video output because are player channel. What I am recording on channel A can be played out on channel B, D at the same time or just D. What I'm recording on channel C can be played on channel B, D or just B. Uh, there is no restriction about that. Of course, if channel A and C are recorded, also the AS audio in channel A is audio recording and AS audio in channel C is recording, then we have uh, channel B and D AS audio, digital audio output. Why we have this kind of a configuration? The um, the answer it's very easy, simple, sorry, because um, we know that every machine has four channels. Then we can maybe set up the first machine for recording channel and the second machine for player channel. The two machines are connected on the SharePlay, then live without any problem. What I have recorded on channel A, I can play it out on channel A on the second machine. But the problem is that if something happen, let's imagine you are recording 4 channel on PWS number 1. If something I mean happened wrong uh, on the machine, instantaneously you lose all the recorded. All the material recorded is lost because we have 4 channel on the same machine. But if we have 2 recording channel here and 2 recording channel there, if one machine will fail, okay, we lose the 2 channel, but the other 2 still in recording, and we can recover the session, uh, of course, without some material, but we don't lose everything. This is the reason why in the configuration we have made a choice to have 4 recording channel, but not on the same machine, but divided on the first one and the second one. Any question?
It's okay.
Okay. So the machine itself, maybe if you go on the rear rack number 4, you can in AQR1 you can see it installed, of course. The machine itself arrives with 4 board. This one is one board, audio video board, and we have 4 board. Each board can be recorder or player. Machine natively use these inputs as HD or 3G. So that means the border comes always with the BNC installed. But in our case, we have this option installed also, which is a 12G SDI I/O. This is video in channel 1 12G, video out channel 1 or channel A 12G, video in channel B 12G, video out, and so on. When this option it is installed, automatically these inputs are setting in off mode, are not working, even if you connect something inside. That means the machine can work in HD, 3G, 12G, but is not auto-sensing, or you cannot change depending on your requirement. At this initial setup, you have to decide if you want the machine in HD 3G, and of course, you don't need it of this one, or if you want to use the machine in 12G, then these BNCs are dead. Of course, if channel A is recorder, we have to supply a video in at this BNC. But if channel A is a recorder, we will never get a video on the output. So this BNC, if it is connected, and in our case it is connected to have a complete system, but is not working because channel A is recorder. On the machine, on each board, we have also a BNC with the time code in. Um, I think 2 days ago we have we talk about the time code, which is a signal with hour, minute, second, and frames. This signal comes from the master generator, and in theory, each board has its time code in, and on each board you can set a different time code. Let's imagine you have the first channel which is recording locally, then you have time code local. The second channel can be a recorder from satellite, maybe from, I don't know, Japan. Then you can supply a time code with the real hour that you have in Japan in that moment. In our case, we don't need this feature. Then we supply just time code in at the first board, and through the software, you can set that all the other channel can keep the time code in this position and distribute over 4 channels. Of course, time code is important in recording mode. That means we have distributed over 4 channels, but is used by only channel A and channel C because B and D are play out. When you play out, the recorded the recorded material contains the real time code that you have supplied in. We have also on each channel 4 AS input. Each input has in AS mode can carry 2 audio channel. That means each board in digital mode external AS IO can record 8 AS channel. um, of course, the output still the same. I mean, this board is a recorder, then we have to supply digital audio in. This board is a player, and this BNC, instead of being input, it become an output. Then the output, digital output audio comes from those these BNCs. Uh, the machine also can use embedded audio on 12G, and again, you can set with the help of the software in PR1, not this is a function that you can set in any moment, is not the initial settings. In any moment, you can say to the machine, please use the AS audio, or please use the embedded one, or on channel A, you can use AS digital audio from external, and channel C, the other recorder channel, you can use the embedded audio on the video. It can be selectable channel by channel. So um, that means if we are using channel B as a player, then we have this BNC with video out. On the video out, we have also audio embedded. But audio embedded is not selectable. I mean, If you record channel A with the AS input, then you play out the channel on this contents on channel B. You have audio in this position through the BNC's output, just audio AS, but you have also audio on the embedded video, the same audio. This is what we have related to the video. There is just one thing more, which is these outputs, which are HD outputs for HD output. And of course, we have four cable, but we use just, in this case, two cables to supply the video to the, sorry, to this machine. Oh, sorry. To this machine, because this machine has also a video input, because on the menu the machine show you also what is going on the input or the output of the video. Maybe this afternoon you can see it on the monitor in AQR1. We have also some Ethernet or network connection. Those two are the each one is 10 gigabit SharePlay uh, high-speed network that can interconnect two different machines, and then I can use this B output, but on this output through the SharePlay arrives some contents from another machine and is output live here. Media file is, there are um, this connection, which is on fiber SFP, which is connected to the media file system and allow us to transfer files from one machine to another or from one machine to an external server or vice versa. Then let's imagine we have an event today, and this event will be repeated with some some contents every maybe Monday for 10 weeks. Of course, we use the machine the first Monday, then we uh, have into the machine some contents, but on Tuesday, on Wednesday, the machine is used for different tasks. Then you can store with the media file the contents for the Monday in an external server, and then every Monday you can load into the machine the contents that you need. This is one of the way how to use it. Or you have done an event, uh, maybe there has been in auditorium a speech from the president, then you want to record and keep recorded that, then through the media file, you can move the file generated inside to an external server and you have a backup. We will see later which kind of a server and which kind of a backup we can use, of course. The machine is supplied with two power supply, and in theory, one is enough to drive the entire machine, but it can be overloaded. That means in emergency, the machine can work with just one power supply, but it's always better to connect both to the mains to have redundancy and to have a good performance from the machine. There is another network which is management, but this is just not for setting, is just a management network. These four connections are not used. Any question?
Yes, Maurizio, please. In this equipment, we have the chance just to record in 12G. There is no HD.
No, 12G, just 12G, yes.
And we have that chance in other equipment in the GMI or not?
Yes, there are in AQR1, CR1, there are 3 recorder HD.
Okay, perfect.
And in AQR2, there is 1 recorder HD. And then you have in Edit Suite 1 and Edit Suite 2 the possibility to record HD, 3G and 12G directly on the edit station.
Perfect. Maurizio, please, here in this equipment, for the 4 channels outside HD, could you please explain
you mean this one?
Yes, those one.
Okay.
The pure format in this equipment, it's 12G. In which part the operation of to translate from 12G to 3G?
No, this is HD, not 3G. And the operation from 12G to HD is performed internally by the software, which has a down converter. Of course, the quality is not so high. I mean, if you connect a monitor here, you can see the picture in HD, of course, but the quality itself is not so high because this is just monitoring output, is intended just to see if there is a signal or not. This is the reason why it's built in with not high characteristics for the down converter, and this one is connected to the Pier 1 computer input, and the computer itself will manage this picture and will show you the picture on the menu. The quality is not so high because it's intended just for monitoring purposes, just to see if you have a black or you have a picture. And if you have a picture, if it is the right picture, maybe you want camera 1 and you see camera 2, then you say, well, my picture in the input of the machine is not good. I have to change something.
Okay, thank you, Maurizio.
Welcome.
Mauricio,
yes.
One question from our friend Mohammed from ENTV. He asked.
Okay, we have a schematics.
He asked.
Please, Marco, can you exchange?
Maurizio.
Oh, sorry.
No problem.
Hello.
He asked you if we can control the PWAS from video mixer through GPIO.
No.
Not for this installation.
It's not provided in our system. No.
In our system. Okay.
No.
Thank you.
Any other question?
Okay.
We can go on. Yes. Please, Marco, can you? Yeah. This is a schematics which relates to the PWS. So as you can see, it's more or less what I have described before. This is PWS. This is the schematics for AQR1, but for AQR2, just change the number of the cable is changing, but the configuration, it is exactly the same. On machine number 1, we have router 25 output, which goes in channel in, uh, and then router 26 output, which goes in input channel C, because A and C are used as a recorder. B and D, they have a cable, but those cable are connected to the patch panel, not to the router. Why we have connected, uh, if you remember, just a few minutes ago, I told you that if the machine is set, the initial setting is input A recorder, input B play, the B input is not used. So let's back. Marco, can you switch back on the machine on the slides? Yeah, thank you. I told you before, if this channel, this one, channel A, is at the initial set defined as recorder, we have to supply a video input here. But this output is dead, is not working, because this output should come from the same board, but the board can be record or play, but not record and play at the same times. This is valid also for the player. So if channel B is defined as player, of course the input of channel B is dead. The output is working, but the input not. uh, Please, can you, Marco, exchange back to the schematics? Yeah, thank you. So what's going on is channel A, router out 25 output. Channel C, router 26 output. Channel B and D are, sorry, terminated over a patch panel. In theory, it makes a nonsense, because you say, okay, the input B and input D will never used. Yes, that's true, but it may be possible that some requirements into the GMA system in the future will change. Maybe within 1-2 years uh, comes up a necessity to have a channel A and B recorder and C and D player, or A, B, C recorder and D player. Well, we cannot imagine now because we don't need it, but it may be possible that in future something happened. That means if you don't have cable connected or cable terminated somewhere, well, it's possible to add some cable, but in a structure which is well defined, require always to do heavy work or heavy rework inside. In this case, we have put a cable which arrives on the patch panel. If for some reason in the future GMA needs to have a different configuration, well, it's easy to have a different configuration. If you remember, when we talk about the patch panel, we said we have some defined position, fixed, and some position which can be used through the patch cord. Well, if PP V1B19 is the input of channel B, it's always possible to connect a patch cord on the video patch panel which connect this input to a router video output. Then automatically maybe I have 25 output on channel A, 26 output on channel C, and maybe 33 output on channel B. Or if the requirement is maybe channel A and B play record and C and D play, then this router 26 output, which is on the patch panel, can be routed through the patch cord directly in V1B19. So what you have to think about the entire system, that basically there is some configuration realized according to, a general view, but through some device like patch panel, audio, video patch panel, or connection through the Ethernet or fiber patch panel, then you can change a lot inside. This is called flexibility of the system. Of course, the same thing happened for the PWS number 2. In this case, we have 25, 26, and that is 27, 28. For the output, we have more or less the same approach, because output A, as you can see, goes to a patch panel. As I told you, output A will be never used because channel A is a recorder. Then on its output, there is nothing. And this is the reason why channel A is connected, terminated over a patch panel. Of course, channel B, which is a real player output, play out, it's connected to router in 30. Channel D will be on 31. Channel B of machine number 2, 32. And channel D of machine number 2 on 33. Again, we can do the same, we have the same reason that we have seen for the input. The configuration now is this one, and it's a general configuration which is good for a lot of events. But if in the future you need to have a different configuration, of course, machine must be reinitialized from the beginning, of course. But you have already in place the connection that you need. Okay. Any question?
Maurizio, please. Inside this equipment, is there
Yes.
any safety mechanism to secure the data inside? Or to recover the data if something happened inside this equipment?
This is a good question. No, I don't think so. No.
So if we lose a part of the record, normally all the others it's useless.
Let's say inside there is inside the machine there are some boards which really are used as hard disk, but really are not hard disk, are static RAM.
More or less SSD,
Uh,
the same. Not
in the
me.
sense that they not use SSD because
It's
they
not.
are too
Yes.
slow for the requirement of the machine.
Yes.
They use a board with a static RAM, really static RAM. If I remember well, are 2 TB each board, if I remember well.
Yes.
But if a board is fault, you cannot recover anything. This is the reason why we have 2 machines and 4 recording channels. Then let's imagine you record the program on channel A here and the program on channel A here, or on channel C as you wish, no problem. If one machine will fail, the other one is still recording and you save your contents.
Maurizio, but this happen when we record, when we play, for example.
Yeah.
If something happen when you play.
Yeah, but if you have the same contents in machine 1 and machine 2, maybe if you have a problem in play out on machine 1, you can use machine number 2 because you have the same signal.
How we can decide that there is a problem and we should change? There is something automatic, there is a mechanism
just
for that?
when
to
you
manage
play,
that?
if you see something wrong on the picture, then you have to use the other one. Simply that.
Manually.
There is LED status on the machine. If it's red, it's you have a big problem usually. If it's orange, maybe one of channel I think is not getting the signal. More or less like this, Mauricio, no?
Yeah, of course. Along the when you are working on the machine, you have the computer connected, which tells you exactly what's going on into the machine. If there is a trouble, if the video is present, if the audio is present, or something else.
The control is always from the computer. It means if there is something...
The control is always from Peer 1 computer,
the
yes.
The computer will tell you directly on the software.
This is the reason why should be an operator, at least one, for 2 machines, but it's better 2 operator, one for one machine and one for another, which keeps control and eye on the machine. Keep an eye control on the machine, of course.
So the last decision, if that happens, it's for the user. The user who decide that should use the equipment number 1 or number 2.
Yeah, consider that. Let's imagine you have output B on the machine 1 and output B on the machine 2 exactly the same. Okay?
Okay.
Then, at certain moment, you find that the output B on machine 1, for some reason, not necessarily the machine, maybe the cable, maybe the router input, maybe something else, but you don't know at that moment, then it's easy. Sorry, I'll show you. Then, let's imagine you have output B in play. Output B goes to router in 30, okay? Then you have set your router in 30, which goes to the output on a monitor through a router. Then at certain moment you have a problem on output B, but output B from machine number 2 still okay. Then through the router you change from 30 to 32, and then you will use this output and you still have picture on the monitor.
Okay, thank you, Maurizio.
Yeah, but there is one question is, if you have to play out and you should be absolutely sure that you have not problem, you have to put in play machine 1 and machine 2, and then send machine 1 on the monitor. If something happens, you press the button on the router controller, and then you change the source to the monitor from 30 to 32, which is this one. Of course, the two machines are synchronized. So if you put in play the machine number 1 with some contents, and you have the same contents on machine number B, both machines receive the reference in as you wish, as you see here. So reference in makes the two machines synchronous. That means in any moment you change from one machine to another, you have the right picture on the monitor and the audio, of course.
If we are recording the same source, because you can put
yeah, of course, the contents must be the same.
4 channel different.
Yeah, if you have different channel, not. Yeah, of course. Okay.
Okay, thank you.
Okay. So let's go on. Marco, please, can you switch back to the slides? Okay. So this is a general view on how the camera switch and power over Ethernet for the camera switch works. If you remember, yes, yesterday, maybe in your slide you have, I told you that we have two switches for camera in EQR1 and two switches for camera in EQR2. But switch in EQR1 are not connected, are not networked with the camera switch in EQR2 because we don't need it. From camera point of view, the two from Ethernet camera point of view, the two control room are completely independent. What we need is the video, not the Ethernet. So the Ethernet switch for camera, the Ethernet switch for camera will connect a PC controller, general PC controller, then we'll connect the receiver for the radio camera, connect the focal point crew, which is camera remote interface unit, and we will see later back. But this unit is responsible to the data back channel from the CCU to the camera. Omar, yesterday or you have checked with the small antenna data back?
Not yet. We didn't
Not
arrive
yet,
to
okay.
this point. Maybe
Anyway,
this afternoon.
the
It's
data
here, the antenna,
transmitted
anyway.
to the camera are originated in this equipment.
Yes.
The camera Ethernet switch also connects the remote DRCP, the remote control unit, and in this case, the RCP is also powered through the power over Ethernet on the desk. connect the master setup unit from Sony. Master setup unit is how we can say it's a general controller for the camera. I mean, with the RCP on each camera, you can check and control many parameters. But there are some parameters which are inside in the deep of the camera, which can be controlled only by the MSU. There are two MSU, one in EQR 1 and one in EQR 2. This device can also act as RCP. And we will see later in the quality control station how to use it. Then we have a Sony CCU, which is called HDCU, which is a camera control unit. And then we have a Sony BPU, baseband processor unit. Just to give you an idea is like this one. RCP is connected through the Ethernet with the switch. The controls in both directions, because RCP sends some commands to the CCU, but also it receives some status. But now, let's say we are moving the joystick here and we are controlling the iris of the camera. Well, if we move the joystick to control the iris means the amount of the luminosity which comes into the lenses. The command is sent to the switch, sent to the HDCU. The HDCU send the commands to the BPU, and the BPU is connected to the camera, and the camera will receive the controls. The position of the iris is, there is a sensor into the camera, into the lenses, and is sent back to the BPU, to the HDCU, to the switch, and then on the RCP we can see a small number, or we can see a LED, a bar LED, which goes up and down and tells us really where the iris position is. This is more or less what happened within a camera controller. Any question? I have to repeat.
Maurizio, please. For the remote control unit in the mosque.
You mean RCP?
Yes.
Okay.
We can work only for one time, one camera, or we have a lot?
No, the configuration inside here, we have one RCP for each camera.
And for the master setup unit? For all?
You can control the camera pressing this button. You can see this button?
Yeah.
This is camera 1. Then you can control camera 1. If you press this one is camera 2, then you can control camera 2, and so on.
So each time one camera?
Each time
in
one
the
camera,
moment? Yes. Okay.
Yeah. Yeah, absolutely, yes.
Thanks.
Any other question?
It's okay.
Okay.
Maurizio, please.
Yeah.
If you remember last time, I asked you about the Fislink antenna.
Yes.
So normally there is a point-to-point connection between the receiver here, the ULRX, to the receiver antenna, and another point-to-point connection from the remote interface unit to the to the other antenna.
Receiver installed on the
The
camera.
transceiver.
Yes, in the next, we have a slide about that. Within some slide, I show you.
Okay, thanks.
Sorry. The RCP, we have two RCP also for the radio camera, which is RCP 17 and RCP 18. So it works more or less the same way. The RCP send a command to the switch. Switch send a command to the Vislink ULRX unit. And the command is sent embedded, to the focal point is sent to the camera. The camera, it presumably will act and move in maybe the iris, as we have seen before. And the position of the iris is sent back through this receiver. So together with the video, there is also a data channel which send back the data to the switch and to the RCP. So the data comes out the RCP, goes to this point, goes to the camera through the RF. Camera will respond through the RF in this way, and then we have on the RCP the indication where the iris is, or if you set a filter, which filter are you using in this way? There are two buttons here that if you move it, you can set the neutral density filter, which allow you to move the filter inside the camera. Of course, it can be 1, 2, 3, 4. Well, but which is the filter that I have now? Maybe 1, okay. In the display appears 1 because this indication comes back through this channel to the RCP.
Maurizio, please. If you put the PWS inside this slide, where is his position?
There is no position inside
Not here.
If we
because
record.
this, no, sorry. Its position is a video recorder, but it is not connected to a camera Ethernet switch.
We don't take the source directly from the camera.
Okay.
Record.
The camera goes to the, I don't know if I told you yesterday,
Yes.
the BP, so yeah, this is important. Okay, thanks for the question because this is important. Why we have, normally we should have just a camera with the CCU. Why we have a CCU and BPU in this case? The answer is because CCU is a camera control unit. So everything the camera can do that through the CCU. It receives command from the RCP, it sends back command to the RCP, the status to the RCP. But in our case, we are working in 12G. And the original Sony HDCU can work only in HD and 3G, not 12G. This is the reason why we have, this is the reason why we have put in the middle a BPU, because from a data point of view, this device is transparent. what the CCU will want to send to the camera goes to the BPU and then goes directly to the camera. But from video point of view, the BPU give us 3 output 12G. Well, really give us more output, but in our case, we have set the machine for 3 output 12G, and we use one output HD from the Sony CCU. This is the reason why in the middle we have a Sony BPU baseband processor unit. Again, CCU and BPU are receiving the same reference signal. So that means BPU and CCU are synchronized, and through the connection between BPU and the camera, also the camera is synchronized to the reference. RCP and MSU focal point they don't need reference blackburst reference. This one needs the the receiver is connected also to the blackburst and is referenced to externally. That means all the video system are synchronized to the master clock, which in our case is GPS to the generator, and then generator outputs to each device. Any question? No? Okay.
It's clear, thanks.
Okay. We have a slide. Let's say okay. Marco, please, can you exchange? Yeah. So this is switch number 1 for the camera LAN. And as you can see, we have some remote control panel connected. Then we have some CCU, BPU, management, and the MSU setup unit, master setup unit. On the second one, we have other RCP. We have one of the RCP for the wireless camera. Then we have HDCU, BPU, and so on. And we have also Ethernet connection for crew and for the receiver. For now, forget those two elements for now. But why we have to use two different switch? Essentially, there are two reasons. As you can see, the two switches are connected together, but it's just a local configuration. There are no other fiber or wire which goes to somewhere, or just a local configuration. Why we need to have two switch instead of one? There are two main reasons. One reason is because we have to we have to supply power to the RCP, and we don't want to overload just one switch with the power over Ethernet. then we have distribute the power from on one switch and on another. But there is another reason, I think more important. If you look at, we have RCP number 1, which means camera 1, and we have RCP number 2, which means camera 2. Then RCP 3 and 4, 5 and 6, 7 and 8. So in alternate position, each RCP is driven by a different switch. That means if there is a problem on a switch, you cannot control the camera. So let's imagine that this switch will die, the power supply will be broken for some reason. Okay, you cannot control the camera in terms of neutral density filter, iris position, black level, color, and so on. Simply the camera fix itself in that position. But you lose the control for camera 1, but you don't lose the control for camera 2, because this switch hopefully still working. So another point, the other point is a single machine can be called a single point of failure, which is in technical term is SPOF. Just a second, please. Why not? Okay. Another term we have to avoid, which is single point of failure. So we have to avoid a single device, which if device will fail, it broke anything. The use of two switch allow us to divide the risk on one side and on the other side. Then we can have not a single point of failure, but distributed point of failure. Any question?
It's okay.
It's okay? Perfect. Oh, yeah, this is a big... Marco, please, can you... Yeah, thank you. I think before to start with this one, we may have a break. What do you think, Omar? Tell me.
Dirons pause l'équipe. Okay.
Okay.
Yes.
15 minutes.
Yes.
It's okay?
Yes, yes.
Okay, thank you.
Thank you, Maurizio. Ciao, Maurizio.
Hi, Omar.
I think we can start.
We can start?
Yes.
Okay. So, here we are. And this slide, more or less, it's very similar to the previous one, but it's only related to the Sony camera CCU and BPU system. We still have a switch, which have already seen before. Switch connected to the RCP and MSU. Then we have a switch connected to the HDCU. In this picture appears what the BPU does. The BPU gives us three 12G SDI output for video switcher, video router, and multi-viewer. This from the CCU we have an HD output, but this HD output is not used, or better, can be used as HD output, of course, but is intended to be a menu output. That means the HDCU has a menu inside which can be operated by some button in the front. And if you check the output, you can set some parameters inside the HDCU locally acting on these switches. Same happen on the BPU, and also BPU has an HD output, but is not connected on the patch panel in this case, but just only on the rear of the machine. And then also the BPU with some switches can be set some parameter internally. We have also the BPU, which is connected with a SMPTE cable to this device. This is a small device which is able to convert the SMPTE cable into two fiber, RX and TX. This because the camera that we use has not the SMPTE connection, but just two fiber connection. Of course, on the camera side, we have a TX, RX, transmitter and receiver, and transmitter on the camera should be connected to the receiver on the SM100, and the receiver on the camera should be connected on the transmitter of the SM100. This device is on the top of the rack in AQR1 and AQR2. We will see later that. SMPT cable connects the BPU, and then we have another SMPT cable, 1 meter or 2 meter length, which connect the BPU to the HDCU. Through this connection, we have video, which goes to the HDCU, HD video, and then we have the output HD. And because the HDCU is not able to manage 12G, so the output that we have HD comes from the BPU. And also we have some other control signal, including a reference signal for synchronization, of course. From the HDCU, we have also one audio channel out, which apparently has no sense because the camera, they have not audio in for some reason. We don't need it. But in case in the future, if something happen and you need to have an audio from the camera, on the rear of the camera there is 15-pin connectors, and these connectors allow you to connect a microphone. Then, if a microphone is connected here, through the system, you have audio output in that position. And as usual, this audio output is connected to the audio mixer. Then, you don't need to add any wire. It's just a matter of install a microphone here on the 15-pin connector. We have already seen the path from the RCP and the MSCU to the camera LAN switch. And the last thing that we have to see is this one, which is called trunk line. This is a special feature built into the BPU, which is an Ethernet connector on the rear of the BPU. Sorry. An Ethernet connector on the rear of the BPU, which allow us to insert an Ethernet line, 1 gigabit, and through the SMPT cable and the fiber, this Ethernet line arrives to the camera. But this trunk line is completely isolated from BPU, HKCU, and camera. It's like an external wire. And the output is on the camera in this position. Here we have another connector, which is an Ethernet connector. So if you connect at the trunk line in a switch, and here on the camera you connect a computer, you may navigate over internet, and the camera still working itself in completely independently one to each other. We use that connection because we use this connection to reach the Shotoku robotics with the mainland switch. I think I have something to show you somewhere. Yeah, okay. Marco, please, can you switch back? Okay, thank you. Yeah, this is a very horrible drawing, but can give you an idea. We have a Shotoku controller. Shotoku controller goes to the main switch, Ethernet main switch. Then the main switch goes to the BPU trunk in. Through the SMPTE, fiber arrives to the camera, and we connect the output of the Ethernet of the camera to the controller in for Shotoku. So what does it mean? Each control sent by the controller makes this path. And then goes here and goes inside here. And you control the robotics. Because the line, Ethernet line, embedded into the signal is completely isolated. But of course, yesterday we saw that the Shotoku controller and computer needs two Ethernet line, main one and backup one. If something happened, the main one is the system change over the backup one. Backup one has a switch. This switch goes to the wall rack 1 at the level S10 in the pre-roll. Then we have an Ethernet cable which arrives to the input B of the controller. So for camera 1.7, each pieces of wire is less than 100 meter. Less than 100 meter means we can use copper wire. But we have 3 PTZ camera also on the mezzanine, which is so far away. We still have fiber optics for the camera on the channel into the fiber optics. It's embedded at the main, and as usual, we keep the output of the Ethernet camera to the controller, but we have to use another path from backup switch to a converter from electrical to optical, and with the fiber we will arrive with the backup to the robotics. We use a connection through a fiber for camera 8, 9, 10, and for camera 1 to 7 we use copper wire through the VR1 and of course VR2 at level S10.
Maurizio,
Any
we are
question?
between wall rack 1 and QR1. Also, we are using fiber.
Between wall rack 1
And
yeah, sorry.
QR1.
Yeah, you are right. You are
Because
right.
there is
Yes,
two
absolutely
switch, we are
yes.
using fiber also.
Yes, absolutely yes. Here we are using fiber. Yeah, because this is more than 100 meter. It's less than 100 meter from wall rack 1 to each column.
To the camera.
Yeah. Sorry, you're right. Yes. Thank you. So, any other question? Okay, let's go. Marco, please, can you switch? Okay, thanks. The device that we saw before, which is the converter between SMPT and fiber, is positioned over the top of the rack, and it's in the middle between rack 2 and rack 5 and 6, because on rack 2 we have all the arrival for the fiber from the remote destination. That means in that position we have also the arrivals for video fiber, which comes from the pre-roll, from many other position, of course, but in this case from the pre-roll. This is the very important things. This is the camera that we use in GMA on the PTZ system, on the robotic system. It's a Sony broadcast camera, which is, its technical name is POV, point of view. Don't ask me why they call it this way, but that's it. It's a broadcast camera in any way. HDC P43, it's 3 CCD, full resolution, each one, 4K. And now here we have the tails of the camera, in which we have the 2 fiber that we saw before. We have a power can be between 11 and 16.7 DC current, and then we have on the rear, this is the 15 pin that I told you before, where if necessary you may connect a microphone. We use power connector, we use fiber connector, and we use network trunk connector. All the other connectors are not used, and the power switch is always on. That means the camera are always on. Let's go on. Okay, yeah. Now we have a very interesting schematics. Really, really interesting. That's it. if you if you see the schematics, uh, we have a drawing which repeats itself many times. This one is identical to that one, to that one, to that one. This means that all the configuration for the camera, all the schematics for the camera are exactly identical and repeated. We need just to check one to have an idea. This is the fiber, and we have two fiber which goes to the converter from fiber to the SMPT cable. This is SMPT cable. As I told you, fiber in should be connected to the fiber out of the camera, and fiber out of this device should be connected to the fiber in of the camera. The SMPT cable goes to the BPU. Then we have three output from the BPU. These output are identical in terms of quality and in terms of timing. Um, they goes to the video switcher, to the router, and to the multiviewer. Output number 4 is not used. It will exist, but is not used. Then we have from the BPU to the CCU. I'm sorry, um, I'm using name CCU because it's more general. Uh, HDCU, it's a particular, it's a name of this device, particular device. CCU can be anything, can be Panasonic, Ikegami, can be anything. All this brand, the interface for the camera is called CCU. So the SMPT cable, we have a SMPT cable which connect the BPU to the CCU, here, that one. Then we have some Ethernet connection, LAN here and LAN, uh, which in some way allow the control of the BPU and the CCU from remote. But this one is very important because through this connection, the CCU receive the data from the RCP or the MSAU. And this is important. Data comes inside the CCU and goes out on the fiber camera here, SMPTE, arrives in BPU and then goes to the camera. This LAN is used only for management process for the BPU. The RCP is not connected on this LAN. So we have a reference in, and the loop through of the reference, which is alpha meter cable, 30 centimeter cable, goes from the BPU to the CCU and keep the BPU and CCU aligned together. Um, yeah, there is a small thing that it's important, but yeah, I would like to spend sometimes some minutes to show you one particularities, which is not related to GMA itself, but it's a general characteristics of the video system, and it is that one. Um, in the old analog world, um, this was a must. You have to follow. With digital, seems to be easier, but really it's not so easier. So let's consider. We have a switcher. This is a video switcher, XVS 7000. Okay. Now we have camera output, camera 1, video output, camera 2, video output, and so on. So, the technological advanced video switcher, on each input, uh, they can have what is called a frame synchronizer. Sorry, frame synchronizer. So, what does it mean? It means maybe the camera 1 has a cable 100 meter. Camera 2 has a cable which is 300 meter. That means if this is my timeline 0, the camera 1, the camera 2 is delayed respect camera 1 because the distance is greater. In the past, it was necessary to align in time all the camera at the input of the video switcher. Otherwise, you cannot mix camera 1 with camera 2. Or better, you can mix it, but you get a noise, you get a lot of disturbances. With the modern with the modern video switcher, each input has its own frame synchronizer, which is locked to the internal clock, and this frame synchronizer receives the first camera, receives the second camera, and puts a same delay here and there to have the two pictures synchronized. This works normally, but it's better maybe once per month or every 2 months, as you wish, to use horizontal phase and vertical phase controller built in into the CCU and the BPU to have all the camera aligned or aligned as best as possible at the input of the video switcher. This will help you to have a better quality in any way. Any question?
Maurizio, please, about the last slide for SMPTE.
Last slide. This one? No.
No. About the connectors. According to this training, normally we have the SMPTE connector everywhere.
On the camera, yes.
There is a connector for SMPTE on the camera?
No, on the camera not.
Why?
Because Sony built the camera without SMPT connector. They built the camera with 2 fiber. Please, Marco, can you exchange the picture? Okay. They built the camera. Sì, okay. Okay. They built this camera with 2 fiber because this camera, it's a broadcast camera, but must be used for fixed installation. If you are talking about other cameras, portable one, when you make a choice, you can make a choice about fiber, SMPTE, or triax. In GMA, we have the HDC 4300 for camera in AQR2, which are connected with the SMPTE cable. And those cameras have the SMPTE connector. Yeah.
So also in the garden we can use this type of camera.
Yes, we will see later, but with the 4 camera HDC 4300, which are in some way in auditorium, really can be used everywhere. Everywhere you have a SMPTE connector.
Okay, thanks.
Yeah, but be careful, because let's imagine this situation. In the garden, we have some SMPT, we have some wall box, okay? And in the wall box, there are SMPT connector, okay?
Okay.
Then, these SMPT connector are point-to-point from the garden to rack 5 and 6 in AQR1. Okay. In theory, I can connect the camera to the AQR1, but the number of CCU and BPU in AQR1 are exactly the number that we need for the camera in already installed. That means if I want to use a camera in the garden, I have to disconnect the SMPT cable maybe from one of the camera of the Cour and use it instead that device.
Okay.
Is it clear?
So totally we have 2 camera with SMPTE connector in the mosque.
No. Give me a second. Marco, please, can you exchange on the... Okay. We have this situation. We have a camera from 1.7 in GMA, in the pre-roll. Camera 8, 9, and 10 on the mezzanine. Correct?
Yes.
Okay. Then we have 2 camera in the Cour and 4 camera on the minaret.
18 camera.
Correct?
Yes.
So everyone has a CCU plus BPU. Sorry. Everyone is right now connected to its own CCU and BPU. Okay? Then on the rear of rack 5, we have an SMPT terminal box. Maybe let's consider that, I don't know if it is true, but in any way it doesn't matter. Connector number 1 comes from wall box 24 in the garden. Then, if I want to use a camera in the garden, I have to connect the SMPTE to the wall box 24. This signal arrives here, and I have to connect with the 2-meter cable, SMPTE cable, this one to the BPU input. But if I do that, first I have to disconnect maybe camera 1.
We replace one camera.
Yes, Maurizio, this is clear. My question is how many camera we have in the mosque with the SMPTE connector, not
We have
only fiber
4.
connector?
4 camera.
This is my question. Thank you.
Yeah, 4 camera that you can use everywhere, plus other 4 camera without SMPTE connector but with RF
Wireless.
connection. It's okay?
It's okay, thank you.
Okay, perfect. So, about the schematics, very quickly. Okay, here we have the schematics. Then, as you can see here, we have audio output, which is already installed. Maybe cable 22-5016. It's an audio cable which goes to the audio room on the patch panel. Then, if you just install the camera, the microphone on the 15-pin connector on the camera, you get the audio from the camera to the audio mixer. More or less the same thing, the same idea is valid for the mezzanine, for the minaret also, as you can see, and here for the core. Because in all these positions, we use the same types of camera, which is a POV camera HDCP 43. So let's go on. Please, Marco, can you switch to the other one? This is a Vislink stationary equipment. Stationary equipment means the equipment in a fixed position to support everything. And then we have the receiver antenna. We have the antenna receiver and down converter radio frequency. The system works between 1.9 and 2.7 gigahertz. Then we have the antenna. This antenna plus down converter are mounted on position in the mezzanine on the support of the camera 8 and camera 10. With the through the coax, they arrive in a wall box on the mezzanine, and from this point through a fiber, this is a converter between electrical and optical. They arrive to this one, which give us back the electrical RF, because convert from optical to electrical. And then the system goes to the receiver. From the receiver, we have 2 video outputs. Those video outputs are not 12G on a single wire, but are 12G on 4 wire. This is the reason why we have at the output of each receiver a multiplexer which transform 4 cable 12G in 1 cable 12G. If you remember, I told, well, we will see that later. Okay, we will see that later. On the other side, we have a focal point device which receive the control from the RCP, send the controls to the power amplifier through a fiber, and the power amplifier send the RF output to the antenna. This is the antenna which send back the data to the camera, this small antenna at 4.433 megahertz. This is a cam device, which is the transmitter receiver mounted on the video camera. The system has some connection. These are two SFP, and each one has two video input, and each video input is 3G, because the camera has the capability to get its output at 12G, but on 4 channel. So that means we have a quad output. And from the camera, we connect the video here, there, here, and there. And this transmitter will send the video using this big antenna. This is the antenna for the transmitter, which transmit to this receiver antenna. Okay? On the side of the transmitter, there is also a small antenna, this one, which receive the data transmitted by this small antenna. This connector, data out, is connected to the camera, and the data received by this antenna through this connector is sent to the camera, and the camera will act what will change the parameter that we have sent the command, iris, black level, and whatever, through the RCP. Through the same connector, the data arrive to the camera, and the camera will answer in some way. If you select neutral density filter B, for instance, or C, I will expect that on the RCP, the number of the letter will change from one to another, just to inform the operator which neutral density is inserted. So the data comes back from the camera to this connector, and then is sent back through the main antenna. This is the reason why we have this green line here, which says the receiver will receive video and audio, but also will receive data, and there is a connection directly between this receiver to the focal point, and this one send back the data to the RCP. Any question?
Maurizio, please, could you give us more details about the wireless transmission because as you know, to send the 4K, you need the very high, it's very high quality and you need very good bandwidth. So how many camera we can manage with only one antenna, and how it's done?
This is this link schematic model to answer you. Okay. This is the schematic model of the system of the VisLink system. So we have two antenna here on mezzanine on camera 8 support. The RF of each antenna goes to a fiber converter, and through the fiber will arrive to rack number 3 in EQR1. Then from the optical domain it is converted to the RF domain and goes into a UHF splitter. What does it mean? Means we have one RF in and we get two RF out with the same content. Those two RF are identical. One RF goes to the radio camera receiver 1 and the second RF goes to the radio camera receiver 2. Then the RF number 2 from the antenna 2 goes to another splitter and the output goes to RF2 in receiver 1 and goes in RF2 receiver 2. Same happen for the two antenna mounted on the camera number 10 on the mezzanine. Exactly the same. It's where we have a splitter and then RF1 goes to input RF3 of camera receiver 1 and here and input RF3 of camera receiver 2. The other RF goes on RF4 receiver 1, RF4 receiver 2. So in this way, if I am in the middle with my camera, I send data to this antenna and to that antenna. Receiver are able to receive my data and let's say the camera transmit over certain frequencies, a fixed frequency. Radio receiver 1
Maurizio,
receive
please,
one camera
what is
and radio
the
receiver
specific
2 receive
frequency?
the other camera. So if I move myself from one side to another, in any way at least two RF channel will arrive always at the right receiver. And then I have the video output. It's a diversity technique.
Maurizio, about the bandwidth and the frequency. For example, how many camera we can receive with only one antenna?
With one antenna, one camera.
Only one.
Look at the drawing. Let's say you delete this antenna and those three, okay? You are there?
Yes.
Okay. If this antenna arrives through directly, not through the splitter, to the receiver 1, okay, you have transmission which is received by receiver 1, but receiver 2 is not involved, because this is one frequency and this is on another frequency. Okay?
This is for redundancy.
No.
This is not redundancy. This is done because the pre-roll, it's very large. And with the radio camera, you can move from one side to another, but you cannot receive camera 1 just here and camera 2 just here, because if you have camera 1 and you move next to antenna for radio camera 2, this receiver will lose everything. In this case, even if you move from one side to another, at least 2 channels will arrive to the receiver. And then you have the video output, still video output there.
So in total, we must use only one mobile camera, not more.
No, 2 at the same time, because you have 2 receivers.
But we should control how we can control the movement of each camera.
No, the moment the camera is handled, you can move, you can bring the camera in your hand and move it.
But each camera should still connect in only one antenna. If they move to one area, everything will block.
No, why?
I don't know.
If you have the camera here. Hello?
Yes.
Okay. If you have the camera in this position, the camera will send the signal to this antenna. Okay?
Okay.
And then you have this antenna which goes to the receiver 1 and the receiver 2. If your camera is transmitting on the frequency receiver for receiver 1, the RF still arrives to receiver 1. And then you can see the picture.
Yes, now it's clear, I understand.
If you move from here to there, the RF arrives at, and your camera transmits on the frequency of the receiver 1, you receive RF here, and then you see the picture in any way.
So we have a target connection between the camera and the receiver when you connect in the first time.
Yeah, because each camera is a frequency
we fix
transmitting frequency, and each receiver has an equal receiving frequency. So let's imagine your camera number 1 transmitted 1 megahertz and camera 2 transmitted 2 megahertz. You have one receiver tuned on 1 megahertz and one receiver tuned on 2 megahertz. This means if camera 1 is moving from here to here, on the output you still have camera 1 here, always. And always you have a signal.
Clear, thanks.
But not only video, but you receive also audio, because camera can have a microphone on it, and the audio is transmitter embedded into the video. Then the output here, you may have video with embedded audio, and audio goes directly to the, because this is not complete schematics, but we have also audio output which goes directly to the audio section of the GMA in the audio mixer.
We can connect 2 microphones on this camera.
Yeah. Yeah.
I have a question. about the antennas.
Yeah, I
How
mean,
do we manage the handover between the two antennas if we have in one RF frequency using one RF frequency for camera?
How to manage the antenna?
The handover between the two.
Oh, it's automatic. It's automatic. It works based on the level and error rate. If uh, let's consider this receiver. Okay. RF1 in this case arrives from the antenna which we have here, okay? And okay, perfect. And this RF number 2 arrives from the second antenna, okay? Is it clear?
Yeah.
Okay, perfect. So if you move your camera from, okay, if the camera is there, and let's say is camera transmitting on 1 megahertz, just a number, is not a true value, and the receiver is 1 megahertz, we have the RF goes through antenna, and then we receive on RF1, RF2, correct? The signal is correct.
Keep going.
It's clear.
Yeah, it's clear. My question was about the handover
Yeah,
between
yeah,
the
yeah.
antennas.
Just a second. Just a second. So now, if you have a transmitter here and you slowly walk about on the floor of the prayer hall and you arrive here, okay, until you are maybe in the middle, you still have signal on this side, okay, on
Yeah.
RF1, RF2. At certain point, if you move to antenna 2, this signal will decrease the level. And on RF1, RF2, the level of the RF and the data, the error data will increase. But at the same time, this antenna will receive your camera. And you have your RF which goes in RF3, RF4. So the receiver says, okay, on the RF1, RF2, the level now is not so good. Let me check on the RF3, 4. And he says, well, on the RF3, 4, the level now it's good, and I will use it. It's automatically inside. It's the receiver who decide if use this antenna or that antenna, according to the RF level and the error data rate. And the same happened for this one, of course.
كونسيبت اسمح لي كونسيبت سي فاسيل انا نهضروا بدو ميكروفون سون فيل انت تهضر وانا نهضر ونسمعوا بعضنا في زوج هذا فريكونس وانت عندك فريكونس اقرا لا فريكونس
Is it clear?
Yeah, it's clear, but can we control that?
Sorry, I have not understood.
Can we control the handover between antennas? You talk about the power. Can we make a threshold to control that? Or is it?
It is an automatic function inside the receiver.
Okay, so it's pre-configured.
Hello?
So it is pre-configured.
It is, sorry?
It is pre-configured.
Yeah, sure. It's this link which has written the software to decide which is the better. I mean, this technical solution is used for also for the radio microphone.
Yes, the same
not
that
only
we
for
are
the
using
video, the video camera. Also, radio microphone use to have, instead of 4, of course, they use 2 RF antenna, and you have 2 antenna, and when you walk on the stage from one side to another, depending which antenna receive the better signal, the receiver will exchange between RF1 and RF2.
Yeah, that's clear. Thank you.
It's clear.
Yeah.
Simply, this is a little bit more complicated because instead of 2 antenna, we use 4 antenna. That's it. Okay. I No, è perché vedo che mi sembra di capire, stanno parlando.
One second, Maurizio, I will explain something.
Hello? Omar, problem?
Not a problem. He asked me why we are using the splitter connecting with both receptor.
Because the antenna has just one RF output. But if I want to supply the RF, one RF at 2 different receiver, I have in some way to generate a second output. This is why.
Okay, 1 second. ريسيبتور الان فيه فريكونس تاع الكاميرا 1 تسمى دوكا انا الا كنت الفوق كونيكتي مع لونتين 1 و 2 سبليتر راح يبعث السينيال الا كنت بالكاميرا 1 الريسيبتور 1 الا كنت بال2 للكاميرا 2 كوتي الدوزيام كيف اوكي موريسيو.
Okay, can go on.
Yes, please.
Okay, thanks. And now we have Shotoku components. Shotoku, it's a PTZ device, robotics, pan, tilt, zoom. And as we have already seen before, Shotoku works with a double Ethernet line, main and backup. Then we have a Shotoku computer, a Shotoku controller system. On the robotics, we have 2 devices. One is Shotoku Micro PDU, which contains all the electronics, is the interface between the Ethernet and the mechanics itself.
Marco, sorry Maurizio, Marco need to switch to the other screen.
Oh, Marco, please, can you switch to other screen?
Thank you.
Okay, I start back.
Yes, please.
Shotoku computer. All the Shotoku system works with 2 Ethernet lines, main and backup, as we have already seen. We have a Shotoku controller system, which is on the desk. This one sends commands to the computer. Computer sends commands to the Shotoku Micro PDU. So every robotics has two components, Micro PDU and Robotics TG27. Micro PDU contains all the electronics and the power supply and receive data on the two Ethernet connection. And through this cable, this connector, big one, with a proprietary cable, it's a Shotoku cable, send the control to the robotics. Robotics contains some part of the electronics plus motors, device, and so on. This is very important because if you need to disconnect this cable from Shotoku Micro PDU to Shotoku Robotics, please first disconnect the power from Shotoku Micro PDU. This is a must because if you do not that, Micro PDU still send high level power to the motor, but the motor are disconnected. And the result is destroy the driver inside. Then, if you need to disconnect the Shotoku Micro PDU to the Shotoku Robotics, first power off Shotoku PDU. Doesn't matter if control here and computer still on. Simply the Ethernet connection is not working. But this cable should not be disconnected with the power on. On Shotoku Robotics TG27, which is this one with the camera mounted on it, there is a small connector with a small cable. I think it's a 1 meter, less than 1 meter cable, which connect this position with the lenses. This cable, it's an RS232 connection, serial connection, and send to the lens the zoom control and focus control. So, from the Ethernet we receive all the controls, including pan, tilt, zoom, and focus. Pan and tilt are used to move the motors inside the robotics. Zoom and focus, they go straight through the electronics on this output and they goes to the lenses. There are some lenses which they are not equipped with this connector, serial connector, but they still have a single connector for focus and zoom. With the special cable, these lenses can be connected on the other connectors on the Shotoku Robotics. In our case, we use, sorry. In our case, we use just one cable serial connection to the lenses. Any question?
I think it's clear.
Okay. We have another system, PTZ, which is Winton. Why we have two different systems? From a logical point of view, it's better to use just one. But there is a problem. So, Shotoku builds up components, robotics, only for internal use.
Studio.
If you want to use your camera in external environment, Kur and Minaret, you have to use something which can be installed externally with the wind, sand, rain, and so on, humidity.
Weatherproof.
And Vinton builds this FHR 155E, which is a robotic built to be in external environment. This is the robotic, and on this robotics we have to install the camera enclosure, because if you install the camera here, the robotics is still outside, but the camera will be destroyed within a minute in case of rain. Then we need also the camera enclosure, which isolate completely the camera from the outside condition. This is the system complete with the robotics, the camera enclosure, and in GMA we have also this option in this square red, which is the cooler, because the temperature inside tends to increase with the sun, and we have had this option which keep cool the internal side of the enclosure. We still have a control panel and the computer which send through the Ethernet the controls to the Vinton system. In this case, we use just one Ethernet connection, not two. It's a different philosophy that they use Vinton compared to Shotoku. Is it clear? Here you can see some installation of the Vinton in this case, and Shotoku in auditorium. But on the pre-roll, it's exactly the same configuration.
The same support we use.
Yes, also the same support, yes. Now we have okay. Okay. Now we move to EQR1. We have a 6-rack. Many equipment are distributed over the rack, and rack 5 and 6 are dedicated to the BPU and CCU for the camera. Then we have in this position video switcher, and we have here fiber connection to the wall box all around the GMA installation. These are terminal point for fiber for the pre-roll, garden, esplanade, and minaret. This is the intercom system, which is present only in EQR1, because we have just one system, one intercom system, which connect all the area. And of course, this device is not present in EQR2. Of course, in EQR2, we have just 8 camera instead of 16. That means rack number six is not present because we don't need it. The power for the rack, or better, the power for the equipment inside the rack is why is not working? Okay, is done in this way. We have multiple sockets connected to a three-phase system, and the mains arrives from UPS. And as you can see, we have um, some equipment connected with two wires because most of the equipment have a double power supply. Power supply can be dual. First, for redundancy reason, if one power will fail, the other one still on, or because the device needs an amount of power that a single power supply cannot supply, but you need two. In any way, the major part of the power of the equipment, they have a double connection on a different phase. That means even if we have a trouble on one distribution power, the other one still working, and mm, it may be possible that the system still on. Any question?
It's okay.
Okay. Okay, perfect. So here we have, Marco, can you switch please to, yeah, thank you. Okay. Here we have some device installed or mounted on the various desk. The device still the same. CR1 and CR2, they have the same device installed. We have this one, which is the remote that we have already seen for the PWS. Then we have some audio monitor connected in video with the 12G or better, connected on the router output. Then, if you route a 12G connection with audio inserted, you will see the picture here and listen the audio, and the bar graph show you the modulation of the audio. The machine, Teranex Audio 12G, is auto-sensing. That means you can send through the router to the audio monitor 12G, but also HD signal. And the Teranex will sense that the signal is HD and will change itself to HD, and you can listen the audio and see the video on the small display. Then we have two different type of router controller. There is a 20 key router control panel, and this one, which is more sophisticated one. This one is dedicated, generally speaking, to control one output of the router. So let's say this 20 key will control output, let's say 53. That means every button is a source. Every time I press a button, I bring maybe source 1, router input 1, router input 2, router input 3, and so on. Every time I press 1, 2, 3, I send the video on input 1 to the output 53. Not necessarily this button must be in sequence. This can be router input 22, this can be router input 39, this can be router input 43, and when I press this one, this input goes to the output 53, always. So this bar controls just one output of the router. And I can send on that output any input which is associated to the button. On this panel, instead, I can make a choice between input and output. So I can set which input I want to send to an output. This one controls just one output. This one can control all the 64 output and send on 64 output any of the 64 inputs. Yeah, this is a simple Chiron Ego, the graphics computer dedicated keyboard, which is connected to the Chiron mainframe through the USB connection. Any question? Okay. We have also an instrument, video instruments. We have really 3 video instruments in in CR1. 3 LV5600 from Leader, which are equipped with different options. So there is an instrument mounted on the video desk which has the option the analysis of the SDI signal, and you can check the waveform of the signal, the error rate, sorry, and many other parameters. Then we have 2 identical instruments mounted on the camera desk. They have different options because they don't need to have to control the SDI options, the SDI signal, but they need maybe to have the focus option. They have a focus option which help the operator to get the best focus, optical focus from the camera because the camera are remoted. You cannot do the focus manually. I mean, you have to do the focus manually by send the commands to the camera, not acting directly on the lenses. This is the reason why the option that focus, it is called the focus assist. This option can help the operator to get the best focus, optical focus. We have also this device, which is a Dante audio monitor. It is connected on the Dante network. It can receive 128 channel, if I remember well, and you can monitor. There are 2 speakers. You can listen, and also you can monitor the level of the audio on the Dante network. We have also a video processor. There are 3 video processor in AQR1, in CR1, sorry, and 3 video processor in CR2. They are mounted on video desk, and they have a video direct from a patch panel, video in, then the other signal are through connector panel mounted on the video desk. So let's imagine we have a 12G video input here. this device is able to convert from 12G to HD. Then I can convert a 12G signal to a simple HD interlaced signal. Why this device is mounted on the video desk and it has associated this connector panel? Because sometimes may happen that you have your computer and you want to send some picture, video, or audio to the system. In this case, it's just simple matter to connect your HDMI output of your computer to the HDMI input. This one goes to the Teranex and you can instruct the processor to bring this video and convert in 12G or HD, and you have the output in this position, and then with a small cable, 10 centimeter, you can send this video to a patch panel. Then any device, camera, computer, whatever that you have in your hand on the video desk, through the processor, video processor, can send audio and video to the system directly. The only limitation is you cannot use Apple computer or Apple device with this system because Apple device are protected by the HDCP signal or control, which is a content protection for the right management. And if you connect an Apple computer, simply your video is black. But this is a problem of Apple computer. Then we have also...
Sorry, Mauricio.
Yeah.
With the Teranex processor, we can also generate tone for make tests and everything.
Yeah, sure. Yeah. Okay, yeah. If you need the... Sorry. The Teranex processor has built-in a signal generator with some video test, like color bars, for instance, and audio test. Then just to check some connection to have along the preparation phase for an event, the processor can be used also as a generator for video and the audio. On the desk inside the CR1 and CR2, we have also the intercom panel RSP2318. In one case, in CR1 and CR2 is associated with an expansion panel, but normally is standalone, which is intercom panel. Through that panel, you can talk to any other section of the GMA installation where another panel is. This kind of a panel can work also as audio in output, but is alternative. I mean, if you use like intercom, you cannot use audio, or you can use it as audio and you cannot use it as intercom. Using audio means you can send to the panel 2-channel audio. Those channel goes to the Riddle matrix, which is, just to remember, oh no, it's not here, okay. Goes to the matrix, the intercom matrix, and the intercom matrix has some audio output which goes to the patch panel, and they goes also to the Dante network through the Rio interface. But you have to make a choice if you want to use the panel as intercom or as audio. This is another way to insert audio into the system. There is, if you look in CR1, if you look at the video desk, on the right there is a monitor, an instrument, and two speakers. This section can work standalone because it receives video from output 48 from the router. And the video monitor, it's a very high grade monitor. Very, very good monitor. Then you can check the quality of the signal and the contents, and the monitor itself act as the embedder. Then there is a level control here and two speakers. So if you have a video connected, if you have a video on router 48 which contains also audio embedded, you can hear the audio on the speaker. This can be quality control for the live events, or if you want just to check some material already recorded somewhere, you can put in play the material and then just check through the router output 48 without use video switcher, audio mixer, and so on. It's very direct. It's easy. This is a controller for the light, because on each column we have two scene light. Scene light LC7 from Harry that you can see here in the picture. This light receives the commands through the DMX interface. Then we have a control interface, which is a DMX out, which arrives to the DMX distributor, and DMX distributor will distribute the signal, the control signal, to the various lights. Some lights on the column, for technical reason, are looped, means we have DMX in on light number 1, and the loop out goes to DMX in to light number 2 on the same column. Other light receive, maybe like on column A1032, we have this one for light 1 and this output for light 2. Any question?
Maurizio, please, could you go back to slide number 24?
This one.
Yes, the Teranex processor. You said that we have 3 in the Mosquea.
In CR1.
Yes, this is according to the number of the operator or according to the number of the source?
No. This is a generic number used by experience, I mean, because sometimes happen that someone comes with its computer and he wants to load something into the system, and at the same time we have someone with a video camera, small handheld video camera with something recorded and want to copy the recording somewhere else. there is no relationship between the numbers and the
So we
operator
can
or
have
whatever.
the same source for several Tyrannex processor.
Yeah, you have a Teranex processor with a connection panel. Each Teranex has its own connection panel. And Teranex are, one Teranex is completely independent from the other.
But can get the same video source.
If you patch cable between each panel.
No,
The video, which video source you mean? This one?
Exactly.
No.
Yeah, this is on the patch panel, but on 3 different positions. So you can send video mixer to Teranex 1 and PWS to Teranex 2.
لي زونطري سيباري وليد.
بصح يقدروا يديو المام فيديو.
راني ما تحتاجش دير لهم المام فيديو، شغل كل واحد يخدم سيباري. عندك في الراك نيميرو 3 لي بانو تاع الفيديو، بانو دو براساج، تلقى تيرانكس 1 تيرانكس 2 تيرانكس 3، راح تروتي لهم لو مام فيديو، ما عندهاش
ماشي بارابور البوزوان، بارابور لي كاركتيرستيك تاع ليكيبمون، دونك ما يقدرش يدير.
سيباري كاريمون سيباري لي زونطري تاعهم. لونطري 1 تلقاها في الراك، لونطري 2 تلقاها في البانو هذاك اللي يجي تحت ليكيبمون في شاك تيرانكس.
ميرسي.
ثانك يو.
It's clear. Thank you, Maurizio.
Sì, ma loro sanno. Sì. Omar.
Yes, please.
Omar.
Yes.
Hello?
Yes.
Can I give you an example?
Yes, of course.
Okay, right now, I am speaking and you can see me on the screen, okay?
Yes.
Okay. What my voice and the picture that you see on the screen is coming from a computer.
Of course.
Okay, perfect. Computer is typical output. It's HD, 60 frames per second.
Yes.
Okay. We are recording this signal on the PWS. Sorry, not P, on the X1000, which is only HD.
Yes.
And we are using a Teranex processor to convert from computer
HD
signal to HD video signal that can be recorded on HD recorder, video HD recorder, including audio.
Yes.
If you want, this is an example that we are using in this,
I can show them
moment.
afternoon.
Yeah, you can show them. Yes,
and
of course.
sorry, on the same time in EQR2, I take a patch from the output of the Teranex number 1 to the input of the Teranex number 2 and upscale the image from HD to 4K, and I'm recording on the PWS in 12G.
That's it. Show them.
Yes, afternoon I can show them.
The capability of the Teranex processor and the flexibility of the system in this way. Okay?
Upscaler. ليكيبمون هذا ليكيب عندك لا سورس اتش دي تقدر تطلعها 4K الا راح توتيليزيها يعني 12G مع لي زيكيبمون تاع الاي كيو ار 1 ولا 2 و سونس كونترير الا حبيت تدي اون سورس توتيليزيها مع نوتر ايكيبمون جوست في الاتش دي تباتشي بالفيديو باتش ومن بعد تهبط لا كاليتي الاتش دي كيما راك حاب. نقدروا العشيه نشوفوا ان شاء الله، نقدروا نديروا تيست ديريكت ونشوفوا الانستالاسيون اللي انا دايرينها باش نونجستريو في لي دو زاباراي. ميرسي. ثانك يو ماوريسيو.
Okay. So this is a little bit more complicated, but it's not so difficult. In CR1, but also in CR2, we have, well, this representation is for CR1. We have RCP from 1 to 8 and RCP from 9 to 18 on the camera control desk. We have the two monitor that I told you. We have a focus assist option, and we have two monitors, high grade, high quality monitors. This monitor is controlled by router out 49, and this monitor is controlled by router output 50. So from the router we have a cable which goes to the instruments, and the loop through goes to the monitor. Then on the RCP there is this joystick which controls the iris and the black level, but also if you press gently the joystick, you can close a small contact, electrical contact. This small contact is connected to MKS 2700, which is a GPI interface from Sony, and a contact close, the interface send on the dedicated VLAN a command to the video switcher, which goes to act the auxiliary 1 output. That means if you press this joystick, auxiliary 1 output will be switched on input 1 of the mixer, which means camera 1. The control goes to the router, and when you press this button, on the output 49 appears camera 1. When you press camera 2, the joystick on camera 2, this will switch on the auxiliary 1, camera 2, and then you have camera 2 here. So in other words, when you press the joystick, on the monitor appears the camera that you have selected. This monitor will show you camera from 1 to 8. This monitor will show you camera from 9 to 18, where the last two are the radio camera. Any question?
1 minute. نو تقدر تبدلهم بالميلونجور، ديزينيهم وتسيليكسيونيهم تاني من او كولكتاك تاع هاد لي كاميرا برك. اوكس 1 عنده لا مواتي تاع لي كاميرا، اوكس 2 عنده لا مواتي الاخرى، اوكس 3 و 4 تيليزيهم دي تريك واحد اخرين. اوكي ماوريسيو ثانك يو.
Maurizio, I have a question.
Yes, please.
How we separate those camera from the monitor? It's based on the mixer or on the GPE?
What do you mean separate?
You said that we have from 1 to 8 camera left and the other in the right.
Oh, simply because if you press this button, this one will control auxiliary 2. And auxiliary 2 is connected to this monitor.
And we can change this configuration, or it's fixed.
This configuration is hardware. It's through a wire. There are wires from RCP to the interface. It's not through software. Each RCP has a wire which send the contact to the interface, Sony interface.
So, for example, if there is a panel with 80 camera, we can do it with only one panel and one monitor.
Sorry, could you repeat, please? If there is?
If we have a panel and monitor that can manage 18 camera, we can do it by only one?
No. No. I think, I don't remember very well, but I think the limitation is on the on this interface. I think that he has a limitation on the GPI input.
That's clear. Thank you.
This is the reason why we use two different auxiliary output to check the camera.
That's clear. Thanks.
Okay. So then, very quickly, we have this is for Shotoku control system. As we have already seen, we have a control keyboard and a monitor. And if you want to see maybe camera 1, we have the Evertz router control panel, and the router 52 is connected to this monitor, and the router 51 to that monitor. Any button you press here, the picture here will change accordingly to the settings of the button. At the same time, let's imagine you want to move camera 3, then you press button number 3 here, and the camera 3 appears on this monitor. At the same time, then you press the button on the control panel, then you move pan, tilt, zoom, focus, and so on for camera 3. But this signal at the same time goes to the input of the Shotoku computer. Shotoku computer has a video input board inside, which allow you to take a picture, a small photo of the picture present on the camera. And this small photo is used as reference. So if you look this picture, there are some photos inside. These are example, of course. But let's imagine you have the camera 1, which is focused on the entrance of the pre-roll. Then you move the camera somewhere. If you have grabbed the picture and you click with the mouse on that picture, automatically the camera will recall the
preset
data and move itself on that position.
When we save the preset.
Yeah, of course. Must be saved, yes. Is it clear?
Yes.
Okay. The same thing happened with the Vinten. Again, we have controller, monitor. This one, which is router output 51. Again, we have a video from router out of 51 to monitor, and then from monitor to the input of Vinten computer. Vinten computer also has a video grab board inside, and then you can use this picture grabbed as a reference point for the position of the camera. Oh yeah, this is the PWS station, where in each station we have a keyboard, mouse, and the controller, and each PWS has its own router output to check the picture, and the PR1, the computer output, where you can send and check the control for the PWS. And set a record, play, sorry, and put the machine in record or stop it, and put the machine in play or stop it.
Configure also the machine, some option.
Something, yeah, not completely, yes.
Not complete, yes,
Yes.
because the complete configuration come from the management PC.
Yeah. Then we have a Chiron system, which is a device that can put a title over video. And even in this case, we have a dedicated keyboard plus a video monitor and a dedicated display for the computer, for the Chiron itself. Simply on this display, you may have a program, then you can prepare your title, and then when you press a button, you will appear your title on the program here in that monitor. Chiron will work in this way. This is a computer, and of course, this is the keyboard of the computer. There is a mouse also. Yeah, there is a mouse also. The output of the computer goes to the display, but the computer itself, the Chiron computer itself, has two outputs. This one is called key channel or alpha channel, and that one is called video fill. What does it mean? First, why we have 4 connectors? Because the board output is 12G but on 4 wire.
Quad HD.
It's a quad output. And then we have a converter from a multiplexer from quad to a single wire. This is valid for the key channel and is valid for the video fill channel. Key channel is a pure black and white channel video and is used, is used to cut a hole in the video. Then when the hole has been created into the video, this hole will be filled with the video fill channel. And that is what happened. We have a video with the title on it. The key video is connected to the video switcher input 19, and the fill channel is connected to the video switcher input 20. The operation to key a title over the picture is performed by the video switcher. Any question?
It's okay.
Okay, perfect. Oh yeah, Chiron-Ego diagram. Chiron-Ego diagram. Okay. It's very simple Chiron-Ego diagram. We have 4 output 3G which goes into the quad SDI multiplexer. And then we have 4 output 3G for the key signal connected to the multiplexer. And then we have 12G output for the fill and 12G output for the key connected to the input 19 and 20 on the video switcher. Okay. Can you change back, Marco, please? And then we have also audio mixer. Audio mixer is Yamaha QL5, which has natively 16 audio analog input here, plus 16 and 16 analog audio output. It can be also connected on a Dante network. It receives word clock, and we have added the audio digital expansion board with 8 in, 8 out. Of course, the number of channel which arrives to the audio mixer is very high because we have 32 channel here. Through the Dante, maybe we have other 64 channel, and then we have AS channel, but we have only 32 slide. What does it mean? It means that the real capacity of the audio mixer is related to the hardware. Even if we receive, if we have available a lot of number of channel, the limitation is the hardware number of slide that we allow us to control the audio and the internal bus system. Through the software, is it possible to assign to each channel, each fader, we can assign an input, different input. This means essentially that when you are preparing an event, uh, before the event, you have to sit down at the table and check and define in a very precise way which kind of resources audio you need and make a programming uh, um, on the system to get that. Then you can save that. You can save a lot of configuration. But this is one of the key point to use mixer like this one. Any question?
No.
Okay. Um, the QL5 audio mixer is interfaced through Dante with device like Rio 3224, which allow us to have a certain number of input. Essentially, we have 32 input and analog. We have 16 output and 4 output AS. Um, this is just an interface, and it is installed in AQR1, AQR2, and no, just in AQR1, AQR2. Yes, 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 yes. This interface will talk with the audio mixer through Dante. If the interface is in AQR1, does not mean that it should the interface should talk necessarily with the audio mixer in AQR1 because it is on the Dante network. Then this one in AQR1 can be associated to the audio mixer in AQR2 through the Dante network. Interfaced on the Rio, we have two interface audio from Riedel, Rocknet, which allow us to insert, to receive and transmit analog audio from the Rio system to the MediorNet system. And then we have the way on how to interface the two systems at analog level. Yeah, now we have mixer schematics. Very, very easy. Very, very easy. Okay. Let's see first in this way. Yes. This is the configuration of the audio mixer output in CR1, but it's identical to the CR2, EQR2. We have the audio digital output AS, which goes to the embedder 1 and embedder 2. These are the main output for the program. So all the signal that we are using, audio signal, arrives to the audio mixer. They can go everywhere through the Omni output, but they are going on program through the AS output. This is the reason why we have inserted this option, MY16 AS channel, into the mixer. The main embedder, receive the AS and put the audio on digital on 12G, essentially. And then we have our program, video plus audio. Now, very quickly, question about that. No. Okay. Very quickly, we can see also, yeah, this one. This is the Rio device that I described to you before with the connection. We have Rocknet interface output connected to the input of the Rio in position 13 to position 20. If you look in the front of the rack in AQR1, you can see it, of course. Then we have 16 output from the Rio We have some input from the PA on the rear, and then we have finally this one, which is ROCnet interface, which receive this line from Rio, and the interface will send this 8 channel on the ROCnet network for MediorNet. We have a Dante primary and Dante secondary, which is a general Dante network, and that means this device can be connected to a mixer in Edit 1, sorry, in AQR 1, or a mixer in AQR 2. We have also 4 AES output from the rear, which are connected to this digital distribution amplifier. Is used for general purposes, but for instance, they are going to the audiometer, which are Blackmagic 12G positioned on the various desk, uh, video desk and camera desk, essentially. Okay, this is another very interesting things which represent us, what I have described to you this morning about the PWS. We have channel A record and channel B record, channel B, sorry, channel C, channel B play out and channel D play out. All this channel, if you remember, was the connector for this channel was a BNC, was not an audio connector, traditional one, XLR, because the machine has the interface on AS on a coax, but we use in GMA on a coax means unbalanced line, but in GMA we use balanced line. This is the reason why in the middle we have a small transformer, which is a balancer, which can transform from balanced to unbalanced and vice versa, from balanced line to coax line, and we should use that for PWS 1 and PWS 2. As I told you before, we have some recorder HD. These recorders are connected with analog audio on the on the audio patch panel, but we have also AS input and AS output digital audio. Even in this case, as we have seen for the PWS, the connection is over unbalanced line, and we have to use transformer to convert from balanced line to unbalanced and vice versa on the input and on the output. There are 3 recorders in AQR1 and 1 recorder in AQR2. In some days ago, we were talking about the MediorNet, and we have seen the some components. One of them was the Compact Pro. even in this case, Compact Pro has AS output and AS input, digital. We are lucky because this input and output are already balanced. Then we don't need a transformer in the middle, but we can connect directly on a patch panel. The Compact Pro has also the 4 audio output and 4 audio input connected to the patch panel. And the Compact Pro also has a RockNet in interface and a RockNet out interface, so that on this RockNet we have the 8th channel from the Rio, which has been inserted into the RockNet by the RockNet interface. All of these things are selectable by through the software, then are completely configurable. This is the instrument. We have this instrument on video control desk, video control desk, video control desk, video control desk, and last one on camera desk control. If you look at the instruments, on each instrument we have, of course, an SDI input, which is not signed because this schematics is related only to the audio, but we have the SDI input, which receive video and audio from the router. Then we have also an AS in from the AS distribution amplifier. Sorry. Be careful, because on the instruments, on the audio meter, there is a small button which allows you to select between SDI in and AS in. Of course, if you are on SDI in and you want to listen AS in, you cannot. But you have to remember always to move on the right input. And more, the instruments can select between 64 different channels on the audio, because 12G embedded on 12G signal we may have 64 audio embedded. There is another small button which allow you to select group by 4, 1, 2, 3, 4, 5, 6, 7, 8, and so on. If you
Maurizio,
expect to receive embedded audio on channel 1, 2, 3, 4, but you are set on channel 5, 6, 7, 8, you will never get audio on the instruments.
only by
This is a
two
common
channel,
error.
Maurizio.
Hello?
Sorry, but the Black Magic allow you to choose 2 channel, not 4. You can monitorize in one time 2 channel, 2 by 2.
2 channels? What do you mean?
You can change, not 4. You said you can choose 4 channel on the same time.
No, I
only
was
2.
referring to the group.
Okay.
I was because the embedded channel are working with the group. Group 1, it's 1, 2, 3, 4. Yeah,
Yes.
of course. The bar graph, it's 2 channel. Yes, absolutely yes. You're right.
Thank you.
Absolutely yes. Yes. We have no audio analog connected. But the last one on camera desk control, we have AS input, SDI input, but also 2 analog input from the patch panel. That means if you want to monitor some analog audio, you can connect this audio on the patch panel A5B09, A5B10, then you can monitor analog audio also. And then we have the last component, which is this one, which is a Rio interface, but instead of being Rio 3224, is Rio 1608. It means we have 16 audio channel in and 8 audio channel out, and no digital audio AS in out. This device is controlled through the Dante network, and each input can be line input with high level signal plus 4 dBm or microphone input selectable through the software. Can be supply also the power to the microphone, the phantom power, acting this button first and then select phantom on the software. Then you can use condenser microphone connected here because the interface can supply power to the microphone also. So, any question?
Yes, there is a question.
Mr. Maurizio, I have a simple question.
Yeah.
How the synchronization done at the embedded level when embed the audio in the video?
Oh yeah, this thing. It's a parameter controlled by. Let me get back. Just a second. Maybe should be. Let me check. Yes. Yeah. We have this board are the main embedder that we use, and inside the software of the board we have some parameter to control the timing, the relative timing between audio and video. And then I think it's already optimized to have a good relationship between video and audio. And we have this on this board, which is from Everts. It's the main embedder. Take in count that this board receives a reference in from the system, and also the audio mixer receive a word clock in, and this word clock is synchronized with the video reference here. That means once you have set the optimal point, this is very stable because both machines are synchronized with the same time.
From the same machine?
From the generator, yes.
Thank you.
Okay. So, I think we have finished for today.
Thank you, Maurizio.
Thank you to you. Yeah. Have a nice lunch. And we will see you tomorrow.
Inshallah.
Okay. Yeah. Thank you. Bye.